So, and the concepts, I mean, the shape of the final is a little bit different than this, but the concepts and everything else are contained within this part. This is obviously just a simplified drawing of some of the overall dimensions on it. And then obviously it goes into the presentation. I sent you a 3D XML file too. You should be able to open that in CATIA.
Let me open it.
Yeah, so here's the 3D XML file that you can use as a reference. Can't do anything with it, it's just dead data. But just to give you an example of what this part has on it, it's drafted, it's got ribs on the inside, and then there's a channel all the way through here that runs around the part like a racetrack. One of the biggest things that it mimics on the final is this little piece on the bottom, which for some reason, probably 80% of the people that try to do the final don't execute that correctly. So if you look at that shape, a lot of people try and model this. They try and model a pad this direction, and then put a chamfer on it. The problem with that is these walls are drafted here. So the easiest thing to do when you gotta build that is to build it from the side. And what I mean by that is the shape, that would be the shape of the pad. And it would be on a plane somewhere in the middle of the park that you would build that. Everybody tries to build it on a plane here instead of on a plane in the middle of the park here. And they push it this direction. And then when they go to United for the Solid, they have issues with it. If you notice too, there's fillets all the way around the edge. So that's the biggest thing too. When they build it like that, a lot of times the fillets don't blend into the part correctly. See something on this part. Go back to this one. So the way this part starts out is obviously there's a part body and there's a body underneath it. Okay, so there's your first, that's gonna be your first sketch, right? And if you look here, you can see where X and Y are. And if you don't know where that is, just look at the 3D XML file. It'll show you where that is. So, nothing strange here, just some overall dimensions on the part. It's fully constrained. And if you notice, this is the center of the part, okay, where that little ramp is on the bottom. And then, so step two obviously is once you create a sketch of it and you leave the sketch, is to create a pad. And it's 125 millimeters deep, the part itself. And once you do that, if you look at it here it's been created, and 3 degrees draft is added to it. Okay, and you can see how the part is drafted. So right in this picture, it's turned over. So you can see the neutral plane is that back piece with all of the hard dimensions. It gets drafted at 3 degrees. So obviously this is the neutral plane. This is a view of it flipped over so you can see the back side. It's this view right here. You can see that the draft is consistent. Just like you had to do with the that wiring trough. So now comes the next piece of it, which you got to give this part some form. Okay, so if you look, there's this radius of 660, and it's basically right there on the center line. Okay, so it's 660 out. Okay, and it's 10 mils in from the edge. That's how it's placed. And then the second part of this one is you take that shape and you build something, you basically build something that looks like this right here. So this is just, once it gets trimmed back, all you're gonna see is that one arc. Because what you have to do is basically slice the solid with this to give it the shape on the back side. And there's obviously the solid, overbuilt to make sure that it's going all the way through the part. There's no draft on it. There's the result. You can see we've got pad, draft one, and obviously another body because we've got the pocket, which is that shape, and they get assembled together. So once those two are assembled, the next thing that comes into play on this part, and like I said, this is step by step, exactly the way the final gets created. It's the easiest way and it's the most disciplined way to get through it. If you decide to do it another way, you may not finish it. On this one now, basically, if you look here, it says edge fillets, all right? So we've got this shape and we're gonna try and put some fillets on the edges of this, and they're 20 millimeters. What it doesn't show you there is, so it says 8 places, it's all these edges, because obviously it was square up to this point with draft. So you can see all those edges. And then once you've done that, you can see here's all those fillets. The next one that ties it all together is this one that's 19 millimeters. All right? So that one's obviously on the back side. So now you've got this base. It's fully constrained. It's got some features to it. And this is the time when now there's this other piece that comes in here, this piece that comes off that looks like a ramp. So if you look at this, obviously this section's right where that plane is. And it looks to me like that's probably a Y plane. So it's right in the center of the part. If you look, here's the sketch. And it's overbuilt. Okay, it goes into the part 10 millimeters. This is basically coincident with the front end. It comes in 15 and then back 44. And if you notice, this says 87 degrees because there's going to be 3 degrees draft on this, but it's easier to put it in the sketch. That way you don't have to go back and draft that edge. So there's 3 degrees on that piece. And then basically that part gets created 40 millimeters, so it must be 80 total. Yeah, because it's from the center out. So it's total of 80. Obviously it's overbuilt, which is good. And then it gets assembled to this body. Now if you look here, there's fillets that go on those edges. So, and those are all 5s. They get all tied together. And then the next thing that happens is you shell the part, okay? And the inside thickness is 4 millimeters. And once you shell the part, if you have all the other sketches good, and you've got good intersections between everything, it will shell. If you've got something wrong, it probably won't shell. Okay, so this is the part that you really haven't seen. I'm going to demo it for you on the actual part that I have. This is basically the profile tool, or it's a subtraction like a pocket, but it's done with the rib and the profile. So if you look at this, this is that groove that goes all the way around the part on the first page. And all I'm doing here is I'm at this center line plane, and I'm going to create this sketch based on these values. And if you look, it's overbuilt. It's got 3 degrees draft in here, so it's open at 3 degrees. So we know that if it's an injection molded part, whatever forms that feature can be removed from the part. And so the rib command obviously gives you the positive, the slot command is going to give you the negative. I'm going to show you how to build that. That gets, once again, that gets assembled, okay? You can see it removed itself here. Then comes the ribs that are on the inside of this part. So there's vertical and there's horizontal ribs. And a lot of people try and build these all as one, but it's easier to do the horizontals and the verticals separate. And what I mean by that is, if you create a set of 3 ribs, actually what, on the part, right, the ribs go like this. And so they come into the part, they look like this in the final part. The issue with that is, it's kind of a pain to do that. And what I mean by that is, if you create them like that, you gotta trim all these edges back to each other, right? Because you'd start out with a straight rib, and you have to trim this one, to trim this one, trim this one, trim this one. It's easier to build 3 verticals, and then the horizontals separate, unite them together, and then you've got this pattern. So it just saves a lot of time to do it like this. If you look at this too, there's obviously 3 ribs in this sketch. You can have more than one element in the sketch as long as it doesn't cross over to another element. So obviously they're far apart, 120 millimeters. If you look, they're overbuilt, that's fine. They're gonna be trimmed down later. Don't worry about trying to keep them exactly on the edge, because when you go and unite them to the part, we're gonna do a thing called union trim, which is gonna trim them up to the inside of the piece. So those are the verticals, and obviously there's a body that they're sitting in. There they are created, and as you can see, they go all the way through the part. And there's the result of those. So obviously it's pad 5. Now they get 3 degrees draft. If you notice too, they're down 10 millimeters from this edge. So that's one thing that you got to start, is 10 mils from the edge. So you could actually have the rib out here and build it down, but you just got to offset this first one to 10 millimeters. That's going to be your neutral plane as well. So this 10 millimeter spot is going to be where everything gets drafted from. And 3 degrees, 6 elements. So it's both of these sides for each one of them. It gets drafted, and you can see there it is, all the ribs in brown. So then there's the horizontals. Same kind of thing for those. They're built in another body, all right, and they get drafted as well. And this is what I was talking about. Instead of trying to trim all these elements back, like you could build that whole structure, but you're going to be doing a lot of trimming in between those. You would just build them horizontals and verticals, turn them into pads, go do what you need to, and then unite them together. Yeah, so here we go. Here there's 4 elements to this, and they're drafted at 3 degrees as well. And the 4 elements are obviously these faces, 1, 2, 3, and 4. Neutral element is the top edge. So now you can kind of see in 3D the draft on both of them. And then right here, step 22, ribs only united. Okay, so these two are added together. They're still not part of the rest of it yet. Okay, they're united together. And this is where we end up doing the union trim. I'm going to show you that. I'm going to show you how to build that rib around the slot. The union trim basically allows you to pick this element, which is one solid, and then it asks you where you want to trim it to, and you pick the inside or the outside, and it'll trim everything away. So that's why there's no need to take a lot of extra time with it. So this one shows you the result and of those two elements, and then that's when it gets assembled to the part body, the rest of the pieces. So like I said, it's going to be almost step by step the same way that you do the actual final itself. Just the final is a little bit different.
Is there any reason you draft the initial pad as opposed to drafting the overall part once it's complete? Or is it just easier to do it that way?
It's easier to do it in its raw form, because when you go back to try and draft something that's united together, it's a lot harder because the edges are in two bodies. And so when you pick a neutral plane, it goes, sometimes it says, what are you trying to do here? So it's way easier to just draft them as they're in their static form and then go back and unite them together. Because all it's going to do basically is trim the edges together, right?
Yeah.
Unless you had something that was dependent on that, where you united two pieces together. In other words, if you had some kind of a wall that once you united it together, it changed its shape or something, then you'd go back and do that one. But these things are pretty prismatic, and it's just a lot easier to do them in their raw form. And it's also a lot easier to pick the faces than when you've got 20 different faces to pick from. Let's see. I'm going to break this apart. So I'm going to hide this off so it's out of the way. So I'm going to delete, define a work object, this one. I'm going to delete the slot. And hopefully the sketch stays. Okay, so there's the sketch. So there's the sketch, okay, that's all the dimensions are on in the part. I'm going to show you basically how you end up, and this is the same for a rib or a slot. So now that I've got the part and I'm defined in this work object, what I'm going to do is I'm going to go to the slot command. And the first thing it asks you for is, all right, what's your profile? A lot of people get the profile and the center curve mixed up. Well, the profile, and if you notice, you can do something on the fly if you want to. That's always going to be your profile, okay? So it's going to be whatever your profile sketch is. Like I said, a lot of people get the two mixed up. Down here it says, all right, what's your center curve? They're basically saying, what are you going to drag this along to build this? Well, in this box, you've got a lot of different selections. You can actually create a new sketch of what you want to drag that along, or you can come in here and you can say create a join. Okay? Well, when you go to create a join, what you need to do is you need to walk around the part and select all the elements. So let me go, I'm gonna pick the inside elements. And if you notice, right here is where, when you go to do this, it starts adding these edges. And you gotta make sure that you go all the way around the inside of the part and you don't skip anything. So if there's some kind of a curve, zoom in on it and make sure that you're getting the last edge of it. Because sometimes if you're zoomed out, you can pick a curve and there may be a short section in it. It's actually, it looks red when you look at it like this, but it's actually not selected. So what'll happen is then it'll fail when it goes to drag that around the edge, because it's as though there's some kind of an open in the curve. That's the other reason I don't usually go from end to end. I usually select these elements unless there's 100 elements. But usually what happens is where it's tight in these, somewhat in the corners, sometimes it'll fail. And that's why I said you might be zoomed in like this, look at this curve and say, oh, it looks fine, but then there's a little bitty gap on it, and when you go to select the next one, it'll turn red, but you won't see that little gap. If you notice too, it here, it says check connectivity, check manifold. So it's gonna come back and say, okay, this is what's going on with this. Right here is the perfect example. When you're zoomed out, it kind of looks like it's just square. Now that I've got those all picked, I think I've got them all picked, I'm gonna say preview, and there it is, it's ready to go. If you do build a solid and it lets you shell it, it doesn't necessarily mean that it's gonna let you do this. It all depends on how good your geometry is. I mean, this is a pretty simple sketch. So if you got problems with that, you got bigger problems building solid models. So it's previewed. I can show you what it looks like. There it is going around the edge of the part. I'm gonna say okay. And looks a little bit different than the preview for sure. I'm not sure why it looked like it was so thin. But, and then obviously that thing gets, in the final part, it gets assembled. And once you assemble it, so if I go up here now and say, we go to this one, say define work object. Assemble this, and there's the slot, and like I said, it's the same thing for a rib. Now, when I do, let me show these again. So you never learned the rib or slot command. That was how you basically executed. In that command as well, go back into this. Like I said, you always need this sketch for the profile, but if you look, if you right mouse click in this blue box, you can do all kinds of stuff in here. You can say, create a sketch, which obviously is the pick next to it, create a join. Let's say you've got some surfaces and you want to actually select those surfaces to create this piece, you can do that. Create and extract would allow you to go in and pick surfaces or elements off of another solid. And then down here, obviously, you've got the same kind of picks. Right here, it's saying edit join one. So I could go back and edit that curve if I needed to. Or if I wanted to, I could say, instead of creating a join, I could say create an extract in here, pull the curve off the inside of that, and then it would exist. You would end up hiding it, but it would exist under this body. And you would have it for future reference. But obviously I followed the inside of the part, which the inside of the part changes, then this changes. And Completely the same for the actual rib itself. So the other thing that you haven't learned is when you go to do a, go up here and see the finding work object, is how to do a union trim. So with all these elements that are drafted, they're already together. That's this body. You end up coming over here and you right mouse click and you say, I want to do a union trim. And what it says here is it says select the faces to be kept or removed. Okay, well, I'm gonna pick on the inside. Actually, what I'm gonna do, let's do this. I'll go faces to remove. I'll pick this one. And if you notice, everything looks like it's ready to go on the outside. I'm gonna say, okay, there it is. It's trimmed itself back. Now if I undo that, I'll do it the other way. I'll do a union trim, and this time I'm gonna say faces to keep. Let's see if it'll allow me to do the inside. Okay, let's see that. There we go. So it's just, you have one option or the other. I'm assuming too that would be for if you had something that maybe didn't protrude 100% through there, that would allow you to go in and do your union trim to just the inside only. This one, so much exaggeration on how far it went outside the part that that's all that's needed. And then if you take a look at the part in the Z direction, okay, so you can see there's draft to it. If I go the other way with this, if I flip this back, let's say I go to the X, and I go to the Z again. Now, guns like this is a true view of that whole thing that we just built. So you can see we're drafted here, okay? And then if you look down inside the pocket, the rib's actually drafted as well. So if you turn it like this, so you can actually see that that's drafted as well. So go through the assignment, and it's obviously not due until next week, but this will give you practice for the actual midterm, or I'm sorry, the final. And if you look too, here's one of the things that when you look at this part, a lot of people, like I said, try and create this in this shape, and then they can't get it to unite, or it won't fill it correctly. Once again, this is another one of those ones where this one should be built. That should be your sketch in the side, which is obviously in the presentation. All you're doing is you're taking that overall shape and you're pushing it from one side to the other. Okay. Any questions on this? Okay. Go ahead and get started. And like I said, it's not due until next Wednesday. And hopefully we can take the final next Wednesday unless there's some kind of strange weather. But that's okay. We got another day in there. So.
So should we expect to be doing the final next week?
Yes.
Okay.
Yeah, that's the what I'll call the safe date for it. Like I tell everybody in the first class, I had it was a summer class about 10 or 12 years ago, and I used to push the final up to the last day in class, and I was walking in here at like 4:30 in the afternoon, and there was a huge power outage. It was when, there was a big transformer down in Ohio that took out all of Metro Detroit for 3 or 5 days. And, so everybody had to come back the next week, which obviously that was the end of school. So they had to come back the next, week and actually take the final. So I always allow now a cushion date in there. So what it means is, if we don't have any inclement weather next Wednesday, you'll take the final. You won't have to show up for the last class, because the grades will all be done and they'll be published. It also allows me to catch up on anybody's grades, and then, because I think I don't think the grades need to be published until like 7 or 8 days after next Wednesday, not after the last class. So there's a little bit of wiggle room there.